So 5.1b is perpendicular bisectors. We already talked about altitudes and medians in the first one from 5.1. And perpendicular bisectors are going to use what we did in 5.1 and start using them together. So you've already seen the word perpendicular and you've already seen the word bisector. So a perpendicular bisector is something that is perpendicular, meaning a right angle, and something that bisects, meaning splits it in half. So take a look at this picture. The line GH is a perpendicular bisector. And the reason I know GH is a perpendicular bisector is because it's drawn on the picture that it is a right angle, meaning perpendicular, and it splits a segment into two congruent parts. So a perpendicular bisector bisects the segment and is perpendicular to the segment. Now we've already drawn this on using a compass. We've had a segment, we had to draw two arcs, and then we drew the line through them. That's what we're doing here. That's the perpendicular bisector, but we're looking at it in triangles. And this is a special case. Perpendicular bisector is a special case because it has to go from the vertex down to be a median, and it has to go from here down to be an altitude. So this is a special case picture. It can look different. You can see a perpendicular bisector where it's off to the side. That triangle won't work. Let's draw a new triangle. Now if I have this, a perpendicular bisector here, if this is the midpoint right here, a perpendicular bisector still goes straight up and down through that point, so it doesn't necessarily have to cross the vertex, and it's congruent here and here. So keep that in mind, that this picture is what you'll typically see, but it's not always the case. It doesn't have to go through the vertex. So let's take a look at this one. We know BD is the perpendicular bisector, and this isn't marked, so let's go ahead and mark it that it does split that segment in half. We need to find x. Since it splits that segment in half, we know that those two are equal. I'm going to subtract 3x and get 2x. I'm going to add 6 to that side, get 14, divide by 2, and get x is 7. So because it's a perpendicular bisector, I'm able to take these two and set them equal because of the bisector. Now I've got a couple different things. I've got angles in this one. I've got two segments. I already know that these segments are marked, so let's go ahead and find y first. Because those segments are marked congruent, I'm going to say AY is equal to, or 8y is equal to 10y minus 4. I'm going to subtract 10y minus 2y equals negative 4. Divide by negative 2. And we get y equals negative divided by negative is positive. So y is 2. And we also know that it says CDF is equilateral. Now that'll help us to take a shortcut. We saw in chapter 4 when we were talking about equilateral triangles that every angle is 60 degrees. So I don't even have to use 3x and 6x in a right angle. I could just take the 6x and set it equal to 90. I'm just kidding, don't set it equal to 90. Let's take 6x, set it equal to 60, because equilateral triangles, all three angles are 60 degrees. So x is 10. An alternate way to do it, I know all three of these, the 3x, the 6x, and because it's a perpendicular bisector, that 90-degree angle all add up to 180. So 9x plus 90 equals 180. 9x equals 10, or equals 90. So x equals 10. We still got the same answer. I think the one in red was just a little bit quicker. And our last example about perpendicular bisectors, and we'll look at proofs of perpendicular bisectors separately. First we want to look at this. If a point on the perpendicular bisector of a segment, if a point is on the perpendicular bisector, like point G, that's the one we're referring to here, then it is blank from the endpoints. So because these are both right angles, they're congruent. These are congruent, and this is congruent to itself. So I know that these two triangles, the left side and the right side, are congruent. And when I look at CPCTC, I know that this segment is congruent to this segment. So if a point on the perpendicular bisector G, then it is equal distance. I'm not going to fit distance in there. Equal distance from the endpoints. We're talking about FG and EG. Let's take a look and see what that actually means when we look at it at a problem. We'll get a picture like this. We know that this, because these are both 2, that it's a bisector, and because of this symbol right here, we're talking perpendicular. So, because it's a perpendicular bisector, I know the distance from F to E is the same as the distance from F to G. So 4x minus 6 equals 2x. I'm going to subtract 4x, negative 6 equals negative 2x. I get x equals positive 3. First question says find EF. So let's plug that in. 4 times 3. We're going to plug 3 in right there. 4 times 3 is 12 minus 6 gets a 6. And since this one's the same, I know that one's 6 as well. Second question is find the perimeter. Perimeter is all the sides added together. So 6 plus this whole side over here is 4. 6 plus 4 equals 16.